Hello, hello. Hi, everyone. We're going to go ahead and do day 2 of our reviews. So let's get started. Okay. So first, it says find the derivative for the following using this specific definition of derivative. So let's go ahead and do that. We see here that we're going to do 1/2 of x plus 1/2 of h minus 1/3, and then minus f of x, which is negative 1/2 of x, plus 1/3, all over h. Now, quickly, we know that we just do derivative, the answer should just be that 1/2, but we're doing it this way, where f of x plus h is just replacing the x, 1/2 of x plus h minus 1/3. And then I just distributed that already, so that cancels out. You're left with 1/2 of h over h. That cancels out to be 1/2. Next over here, we have the square root of 9 minus x minus h minus the square root of 9 minus x over h. Well, we're going to do a trick where we multiply this with 9 minus x minus h plus 9 minus x over that same thing. And we know that we'll get 9 minus x minus h. And then we'll get minus 9 minus, or no, plus x over h times 9 minus x minus h plus 9 minus x. These guys will cancel out, and then the h's will cancel out. Or let me do it by step, because I noticed that sometimes we skip that step prematurely. 9 minus x minus h plus 9 minus x. Then you cancel it out, and you get negative 1 over both of those square roots. And then at this point, you can use the fact that the limit is as h goes to 0, and you can just plug that in, and you'll get negative 1 over 2, because you'll have 2 9 minus x's after the h becomes 0. And that wouldn't be indeed your answer if you did the derivative. The negative would escape because of chain rule, and then we know derivative of a square root just like that would be 1 over 2, and then square root's on the bottom. All right, let's do this over here. We got x plus h to the power of 3 minus x to the power of 3 over h. For this, I'm going to use the binomial formula that states that using binomial coefficients, you can reconstruct any polynomial like this. So that's what I'm going to do. Or you can take a beat and just do it on the side. It doesn't matter. X to the power of 3 plus, what is it? Was 1 choose 3 is 3 factorial over 1 factorial, 2 factorial. Yeah, so it's 3. So 3x squared h plus 3x h squared plus 3h cubed minus x cubed over h. These guys would cancel out. And you're left with 3x squared h plus 3x h squared plus 3h, or wait, no, that 3 is not supposed to be here, excuse me. H cubed over h. Then you can divide out the h, you'll get 3x squared plus 3xh plus h squared. And then you'll take the limit at that point, set h equals 0, and you'll just be left with 3x squared. after you take the limit. And again, we know that that's derivative. For here, we'll get this, a similar thing. Let's go ahead and I think it'd be better if we just rewrote it as a square root first. So x to the power of 3 square root. So we get the square root of parentheses x plus h to the power of 3, then minus the square root of x cubed over h. First, I'm going to do this trick over here. So that basically gives me x plus h cubed minus x cubed over h, and then times the cube root of x plus h cubed plus the square root of x cubed. And I'm just going to copy and paste what we got from the top here to get 3x squared h plus 3h squared plus h cubed over h. The same thing, x plus h 3 plus x cubed. Divide out the h's. Actually, I should have just copied it from here, but either way. 3x squared plus 3x, or 3, no, just not x. Wait. Yeah, there's an x. Excuse me. I'm going too fast. xh, and then plus h squared over this guy. X plus h cubed plus square root of x cubed. Then from here, you can now take the limit. Keep in mind that we haven't been taking the limit before because just recall that we don't divide by 0, so that we had to do some algebra to make sure we're not dividing by h anymore, which again would be dividing by 0 because we're saying h to be approaching 0. So then now it doesn't matter if h is 0 in this case because we won't have a dividing by 0 situation. So on the top, you'll have 3x cubed. On the bottom, you'll have two sets of the cube root of x, or the square root of x cubed. And then from here, we can, just going to rewrite that as a power. 3 over 2. And then I'm going to go ahead and, excuse me, and then I'm going to go ahead and just combine this. So 3 over 2x to the power of 2 minus 3 over 2. So that's 4 over 2, and then we're left with 1/2. Or 3 over 2 square root of x, which it pretty close to us just using the power rule anyway. So we're done. I still don't know at this moment if one of these problems will make it into the test. It probably will, but I'm not gonna say like for certain yes or no. So just keep that in mind. Okay, all right. Next one. All right, we're doing implicit differentiation for this one. So let's go ahead and figure it out. Now remember, the idea of this is that y is a function of x. So in finding its derivative within a chain rule, we have the issue of knowing that while we can do derivative, it's a function. So we have to multiply it its by its chain if it's within a chain rule situation. So for example, here, if I'm doing, I'm going to do notation of writing it as prime for all of these. We know that because it's just adding, and it's one side, we can do the prime of these guys individually. So x cubed prime plus y cubed prime is equal to 1 prime, which that's just going to be 3x squared. That's going to be 3y squared, but then chain rule, we don't know what y is, so we're going to multiply by y prime, and then 0. Then from here, if it says to solve for that, that's what we're going to do. We're going to subtract 3x squared from both sides. 3y squared y prime is equal to 3x squared negative, and then divide by 3y squared y prime is equal to negative 3x squared over 3y squared. And then you can simplify these a little bit, and you'll get negative x squared over y squared. Or I would just accept this as the answer, but technically, if you want it to be, you could do this as well. But I don't think it matters personally. Okay, that's going to be it for that one. Let's go over here. So this one is, it seems like we're going to have the issue. Well, we can take out 4. We have to do the prime of cosine x sine y using the product rule. I already did the derivative of 1, and then 4 just gets to escape. So for here, let's do derivative of cosine first times sine. Derivative of cosine is just negative sine of x, and times this one sine of y. And then now I have to do derivative of sine y, which is cosine of y. But I have to do derivative of what's inside it, which is just y prime. So now I just need to solve for y prime. I'm going to take advantage of the fact that this is equal to 4 and divide by 4 from both sides to get 0. And so I have cosine of x, cosine of y, y prime, negative sine of x, sine of y. I was about to skip a step. I'm going to add sine x, sine y to both sides to get cosine of x, cosine of y times y prime is equal to sine of x, sine of y. And then I'm going to divide both sides by that. So you have y prime is equal to sine of x, sine of y, over cosine of x, cosine of y. And then I'm going to go ahead. You don't have to do step. I think that I would set that as the answer, but I'm going to go ahead and just replace that with this definition, tangent of x, tangent of y. Right. And that's going to be the answer for that one. Okay. All right, next prompt we have here. So derivative of the left-hand side is just going to be 1. The right-hand side is going to be 0 plus this expression, which, again, is a similar product rule idea. So we do 2x y squared plus x squared 2y y prime. Subtract this. We'll have 1 minus 2xy squared is equal to x squared 2, or 2, put the 2 in the front, y prime, and divide by that guy to get y prime is equal to 1 minus 2xy squared over 2x squared y. Okay. And then the last one. Now this one seems pretty easy. You just do derivative of this and this. We get 5y4 y prime, and then minus sine of x equals 0. Because the prime of 0 is just going to be 0. Any constant derivative is going to be just 0. Add sine to both sides, and then divide by 5y to the power 4. Sine of x, 5y to the power 4. Pretty straightforward for all of these. We just have to remember this technicality, that y would be a function of x in this context. All right, similar to implicit differentiation, perform the derivative with respect to t for all the following. Assume variables are functions of t. So we have an easy one to do. For this one, I'm gonna stick to the prime notation just because I prefer that personally. So we have a is equal to pi r squared. So it's a prime is equal to the pi escapes, and then the prime of r squared is just 2 pi r, and then r prime. Over here, this is v prime, and this is 3s squared s prime. Pretty straightforward. This one is probably the ugliest because it's going to be like a product within a product. We know the left side is just v prime, but let's do. Let me just rewrite it first. L times W times H prime. Let's go ahead and just rewrite this as L prime times W times H plus L times the prime of W times H. Which for that one, we know we can rewrite as W prime times H plus W times H prime. And then distribute that L. And you'll see we just have this pattern where one guy is prime and the other two are not. Pretty straightforward, pretty neat. Yeah, that's pretty much it for this one. Oh, I forgot to box that too. That was a bit quick. Oh, okay. Right. So right now we've just been reviewing implicit differentiation and just fine-tuning some of our algebra a little bit. Um, I've noticed in grading test 3 that we do need to polish our algebra, so please keep that in mind, okay? I give you partial credit as much as I can, but it's not gonna save anything. Okay, let's do this one. So this is a Riemann sums question. Approximate the area underneath 2x squared on this interval using a left Riemann sum with n equals to 4. And I'm copying the test format where I gave you like the formula. So for here, we know the width is the ending point with the starting point. For rectangles, it says. So it's just 8 divided by 4, which is 2. Okay. So that means our endpoints is going to start at -2, because it's -2 and then 0, but then we're going to add 2 to each. So that's 0, that's 2, then that's 4. And then we're going to just multiply this function with that input times everything. So let's see. So we have, excuse me, I burped. F of x0, which is just 2 times -2 squared, which is 4, so 8. F of x1 is just 0, makes the whole thing 0. F of x2, it's going to have a similar effect here to where that's also 8. And f of x3, 16 times 2 is 32. So that means we have 2 times 8 plus 2 times 0 plus 2 times 8 plus 2 times 32. 16 plus, I'm not even going to bother doing that one. 16 plus 32. 32 times 32, or 32 plus 32, excuse me, is 64. So that's our answer. And if you wanted to on the side, you could just perform the integral from -2 to 6. And let's just do it real quick just to see. We got 2x squared dx. Using the power, we can simply say that that's going to be from 2 over 3 x to the power of 3 from 6 to -2. So, let's do that a little bit on the phone because I know, for example, that's going to be -8 because -2, or oh no, +8 actually, because it'll be minus a negative, and -2 to the power of 3 is definitely going to be 8. -8, excuse me. So I'm just double checking for fun. But then if I do um what is it, 6, I get 216. So 216 plus 8 is 2 over 3 times 224. And we said that the answer is 149 to 3 all the way going. So, okay, funny enough, this is not the best example with the Riemann sum about how it approximates it, but it does serve as a good indicator of how the more rectangles we do, the closer we should be, and how probably more rectangles would do this just a little bit more justice. So I apologize for this being a kind of a little bit of a misdirect, but it's good practice that we do this either way. Okay. Um, let's go ahead and move on to the last problem. So the last problem reads, find the integral, definite integral from 6, 7 of f of x dx for the following f of x's. So we only have 2. Okay, so for the first one, we know that the integral is just going to be ln of x from 6, 7. So that means we're going to go ahead and do ln of 7 minus ln of 6. And that would be your answer. All right. You would get some approximation, but that's basically the answer. Here's a little bit trickier because I gave you something that's not as straightforward. For here, we're going to have to use just a little bit of u substitution. And ask ourselves, well, it'll definitely be easier if this whole thing was just u. But then we need to figure out what's the derivative of that. So derivative of this would be -4 dx. But the problem is that -4 is not there. But we can force it to be there by dividing both of these sides of this equation by -4. So you have 1 over 4 negative du is equal to dx. So we replace this guy with u, and then only this guy with -1 over 4 du. -1 over 4 e to the u du. Then we get, write this down, -1 over 4 eu from 6 and 7. Then we plug in back u, so -1 over 4 e -4x from 6 and 7. And then this can just be -1 over 4 parentheses e to the negative, that's going to be -28, and then minus e to the negative 24. And that would be your answer. If you want, you could, type this into a calculator, but you would get just some approximation and not the exact full answer that this provides. And also, I think this number is technically a little bit too big anyway. I'm typing into the calculator right now for funsies. And or not, oh, it's not too big, but it's one of those things where it's like an annoying detail. I don't know if you can see that. So yeah, we might as well just leave it as this. All right. Um, please be looking over all of our previous review videos, all of our other study videos, all the material. Let me know if you guys have any other questions. This one was kind of quick because it was just derivatives, and at this point, the derivatives are a bit like just kind of naturally. The longest part of this video was probably this first page, but we also need to make sure that our algebra skills are up to tip-top shape. So please keep that in mind. On the test, we asked this question, but we asked it in the form of like a story problem. So remember the difference between this and the story problem. Remember that from Unit 3 where we talked about like just if functions in general, then we turned them into stories towards the end of Unit 3. So just keep all those details in mind, guys. The videos are up, they're not going to go down, so you could technically watch all of them before the final, but you just need to be mindful, okay? Um, yeah, that's going to wrap up today's video, guys. I wish you the best. Let me know if you have any other questions, and I'll see you all. Oh, actually, I won't. This is the last video. Well, I wish you the best of luck. You have the potential to reach out to me for any of these next couple days. I'm going to be grading everything as soon as I can so we have the best outlook of what you need to get on the final for your grades. Um, yeah, that's pretty much it, guys. I don't know how much more warning I can give. So, best of luck, guys. I hope you kill it, okay? All right. See you all when I see you. Maybe stop by my office in Tarleton. Bye bye.